Hello, welcome back. In the last few lectures we've been talking about covert channels and what they are, how they work, and I gave you a few examples of covert channels. In this lecture I want to talk about how one goes about finding covert channels in a system. Right. Remember last time we said that for there to be a covert storage channel, at least certain things had to be true. There's an attribute of the system which is shared by the two processes. It has to be the case that the sender has modify access in some sense to that thing, or can do something which will modify that attribute. And the receiver has to be able to do something which will reference or view or look at or see some property of that entity. And it also has to be the case that the two colluding communicators are able to synchronize their activities in such a way that the sender, for example, knows when to put the bit there and the receiver knows when to take it. Okay, so that suggests maybe that you might be able to have a systematic way of looking for covert channels in a system. And a guy named Richard Kimmerer from University of California at Santa Barbara came up with a methodology which he called the Shared Resource Matrix methodology for doing exactly that. What's the idea? Well, you build this table and you label the rows of the table with the various attributes which might be manipulated by some program, and label the columns with the various system calls that you can make in your system. So for example, here's a matrix, and we looked at the attributes of file existence, file size, and file level. Those are things that might be changed by various programs, right? And then the operations that we looked at are read, write, destroy, and create, our familiar operations from those that system that we talked about earlier. Okay, well, how do you populate the table? Well, you put an R in a particular location of the table if that operation ever gives you information about that attribute. So for example, in this system, for example, read gives you information about file existence. If you ever read a file and get an answer back and get contents back, then you know the file exists. And so that tells you something about that attribute, namely that the file does exist. How about M? Well, M is there in a location in the table if that operation ever changes or modifies that attribute in any way. So for example, destroy, that changes file existence because it causes, in some conditions, the file to go out of existence. Right. An important thing to note here is that you have an R or an M if this happens in any circumstance. It doesn't have to be that it always happens, just that it can happen. Okay, and notice one more thing. This table works pretty well for storage channels, but it doesn't do much for timing channels. Why? Because the attribute that you're manipulating in a timing channel typically is something like the real time or the ordering of events or something like that. And that's a harder thing to pin down. Okay, one thing that I want to call to your attention, a proviso sort of, is it's a little subtle sometimes whether to put an R into the location in the table. For example, consider the operation create, which we looked at when we were building that simple covert channel system a couple slide sets ago. The semantics of that was S tries to create an object, and sometimes that works and sometimes it doesn't, right? But after S performs that operation, you can be sure that an object of that name exists on the system, right? And so you might think, well, you should have an R there. If I do a create, then file existence, I should have an R because I know that that file exists. Why? Because either it already existed, in which case the operation failed, or it didn't exist, in which case I created it. So I know that it's there. The subtlety is that the operation create doesn't tell me that fact. And so I don't get that information directly from the operation. I have to infer it. And so it would be difficult to use create if you were the receiver on a covert channel to get that information. In fact, you couldn't. And that's the problem. And so we don't put an R on the file attribute create cell in the table. Okay, So we built this table, and we've got these R's and M's in there. So what? Well, the answer is any row in which you have both an R and an M tells you where to look for a covert channel, right? Because the R and the M on a particular row says that for that attribute, there's a mechanism by which someone can modify it and someone can reference it. And that's, remember, what you need for a covert channel to exist, right? The thing is that the presence of the R and the M in a single row doesn't tell you that the channel is necessarily there. It just tells you that it might be there. And so you have to look carefully at the system, the semantics of the operations and the system implementation to make sure it is there. But this gives you a systematic way of looking for channels. The other thing to note is that when you build one of these matrices, first of all, it's hard to do because you have to know a lot about the semantics of the system and the implementation to know what the attributes are and to know how these operations affect those attributes. And the other thing is the table is very specific to a particular system. And so you change the semantics, the table would have to change. Okay, so you can use this technique now to look systematically for covert channels. Well, suppose you're building a secure system, how do you use it in that context? Well, typically what you might want to do, and this has been done for a lot of different systems, you use Bell and LaPadula as your standard policy, and that closes the overt channels. And then, after you do that, then you apply this methodology or some other methodology to look for covert channels. And once you found them, then you figure out what to do with them. Remember, there were various ways in which you can deal with a covert channel if you find it. So what have we learned? Well, we've described Kimmerer's shared resource matrix methodology, which is a systematic way of looking for covert channels in a system. Using it effectively requires a lot of knowledge about the semantics of the operations and the implementation of the system. But it's just a tool, and that's what it's good for. And then once you've found the covert channels, then you still have to decide what to do with them. Thank you.